Hey folks, good morning. Welcome to today's lecture. I haven't quite started yet, just getting myself sorted out. Good morning, Tanvir. Someone's up bright and early at 10 a.m. on a Monday. Good morning, Melody, always here as usual. Turn my, whoops, where's my remote control gone? Here it is. Good morning. Folks, it's another great day for making some interactive art with computers here in COMP1720, 6720. Thank you so much for joining me, those who are joining me live and chatting in Teams. It's always super good to have a great team contribution in the lecture. I was getting my other computer out so I can see what's going on. I do like to see what's going on during lectures. I've got too many devices here. I'm trying to have like my iPad as the remote controller for OBS. I'm trying to have my little laptop here as a Teams machine so that I can see what's going on in the chat. Teams. Maybe I'll just use Teams in Chrome, because Teams in Chrome sometimes seems to work better. Good morning, Emma. Great to have you as well. Go to Mail. Go to my team and check out the general chat. Good morning, Zephan. Too many teams. Does anyone else have a too many team problem? Here we go. Good morning, Chanhang. Good morning, Yumin. And good morning, Huangvu. And good morning, Isaac. Great to have you all. Folks, we're going to get started because even though we have 2 hours, we tend to use up the time, which is wild. Today's lecture is variables and chance. It's variables and chance week. I'm just going to check Restream to make sure that I look the way that I'm supposed to look. Oh, not sign up for free. I want to log in. Why do websites not just give you log in as the first option? Let's keep that muted. I think I look fine. Today's topic is variables and chance. The vibe here is that last week we learned how to create shapes, create colors and paint in P5. And this week the focus is on storing information over time. Getting new information, and adding movement to our sketches. So everything we did last week was flat and static. So we could draw a picture, but it would never change. And so we have to learn how change is represented within P5.js, and that's what we're going to do today. And it's important to then account for this computer science topic of storing information in a variable and having information that changes over time, even if you aren't the one who changes it. So that's variables and chance. And we will connect it to art, as usual, the art world, art history. So a few admin points. If you ever miss a lecture, you know that you can go to the lectures page and click one of these links and you'll find, oh, I've got to make sure I'm recording actually. Whoops. I'll go back to the start. So it looks like a good recording. Start recording. Folks, welcome to COMP1720. I accidentally didn't start the recording, but I was only speaking for about 2 minutes, so we'll get to the handle of it. Today's lecture is variables and chance. A few admin points before we start. If you ever miss a lecture, which the folks who have confused about the fast start of this one will have, you can always go to the lecture page and see a recording of the lecture on Microsoft Stream, on YouTube or Twitch, or on Echo 360. I make sure I upload the recordings to Echo 360 shortly after each lecture. I also have the lecture slides available. Someone asked me on the forum yesterday where they were because they disappeared. Something was going wrong with them, and something's still a bit wrong with them. They don't look the way they ought to look. I'll try to fix that today. They're halfway cut off, which is confusing. Excuse me. It might be a tough lecture today. I've got a bit of a cold, so my voice may run out of puff. I'll try to talk quietly. So the lecture slides aren't looking great in the PDF version. I'll try to resolve that. Make sure you go to your lab this week. Labs start today. You've got a pre-lab task to do. Whoops. Just make sure I take a second to cough and then I'll come back. Whoops, sorry about that. You'll just have to bear with me today. Every week in your lab, you need to prepare for your lab by doing a lab task and putting it on the forum. First one's due this week, so make sure you read that. Read the procedure. Boy, I'm having a real trial this morning. I don't actually have COVID, I just have a regular old cold, but it's interacting with my lecture tone of voice for some reason. I'll try to start again. Whenever you go to your lab, you have to make sure you've prepared your pre-lab task, which is uploaded to the forum. So I've got my water here. Thanks, Melody. Stay hydrated. Very important. Your pre-lab task has to go on the forum. We've had a bit of an issue with the forum with folks not being able to get in, but I think that's mostly resolved. I can see that there's now a lot of things on the forum. Everyone who does their pre-lab task should be putting it in the pre-lab category. And it's really important you do that. If you don't put it in the pre-lab category, we don't actually find it and don't give you the mark for it. So I can see there's someone who's not done that here. Art can be anything. Oh, that one was deleted for some reason. The meaning of art. So great post, but I'm just going to edit this and make sure it goes in the correct category. So no worries, person. That one's solved. We actually try to clean these up as we go if we find ones that are in the wrong place, but it's always better if you do it yourself. So make sure it's in the pre-lab category, and it also needs a week 2 tag on it. So that's not so hard. Second thing, assignment 1. Oop. Assignment 1 is out. Your goal for assignment 1 is to make a monster that moves in P5. It's not supposed to be a hugely scary assignment, but it is due quite soon. This is due in week 4, 15th of July of August, sorry. So your task here is to actually get started this week. I really need everyone to give this a go. It's actually an assignment that you will have all the tools to do after today's lecture, so you don't need any more information after today to get started and do a great job. But you do need to get started in order to get used to the submission procedure in 1720. If you've never done this before, if you haven't used GitLab, it can be a bit of a trial to start with, so just try to get yourself started there. Last thing, make sure you've checked the course forum and got your email notification preferences sorted out, because the course forum is how I give you important information like feedback on your assessments. So if you haven't got email preferences organized, there's a little FAQ article here. How do I manage my email preferences? Make sure that you've got that organized so that you get emails whenever I send you a DM on the forum. And that's how I'll be sending you back your feedback, or one of the ways you'll get your assignment feedback. So just to go through the requirements for the monster, I didn't talk about this a lot last week. I said that your idea is to make a monster. The broad idea is that you have to make a monster that's interesting, coherent, and has personality. So it has to be an artwork. not just a cartoon, right? For something to be an artwork, it has to be more than. It's got this excess of je ne sais quoi. And I'm trying to express this through those three different aspects: interestingness, coherence as an artwork, and personality. I don't want something that looks like you've just slapped random stuff together. I want it to feel like you've thought about what's going on. And the one tricky requirement is that your monster actually has to move through time. So you don't know how to do that yet, but today I'll teach you how to do that in P5, make something that moves through time. I'm just going to go over the basic requirements here so you can see what you're supposed to do. So the requirements are, you have to make a monster. It could be biological, mechanical, energy-based, anything, as long as it's a non-human creature. It has to be interesting and coherent, so you have to use what you know about drawing shapes and colors in P5 to make your monster an artwork that grabs the viewer's attention. And you do that through artistic coherence, using elements that work well together, and having clearly interesting elements that people want to look at. The have personality bit is more to do with movement, so it should seem like there's depth and character to your monster. It's not just a bunch of shapes thrown on the screen. It should feel like it's coming out of the world. And it has to move in some way, so you need to use frame count or another method, we'll talk about a few today, to make your monster move so that that will help it give it that personality. The other things are quite more like limitations. This can only be an 800 by 800 P5JS sketch, very simple requirement there. You have to include a static image file of your monster, which is easy to do because the assignment template includes a way to get that to happen. You have to write the P5 code in the sketch.js file, that's easy. You also have to write an artist statement, short artist statement, maximum 200 words, describing your artwork, and we've got some requirements for that below. And then in your references file, you actually need at least 2 references. So it's got a blank references file isn't acceptable in 1720. Everyone has to refer to something. One of your colleagues, the manual, things you found online. Any reference is fine as long as you've got at least 2 of them. You don't have to have a background behind your monster, but you can if you want to. That's not a requirement. Now, a few must-nots here, because many folks get into P5 and they run straight ahead into various techniques, but I want everyone to just focus on the basics at this stage and make this an easy assignment and focus on the aspects that we've learned so far in the course, not on you yourself discovering different parts of P5. I want everyone to discover these together and to fit them into the context of the course. So, first of all, you must not use image. This is not about creating images, it's about drawing in P5. You must not use sound. We're going to study sound later. And you must not use interaction. We're going to study interaction later as well. Then, finally, before we go on with the lecture, a few notes about your artist statement. Your submission must include an artist statement. You've got to explain in that what your artwork is, how you made it in P5, and why it's an artwork at all. So just explaining these main requirements to me. How is it interesting? How is it coherent? And how does it have personality? And if you can explain that to me, that's great. I don't have to worry about figuring it out for myself. It's much easier for me to give you marks for meeting that requirement if you just explain it carefully and clearly to me in the artist statement. The rest of the instructions here are more or less just details about the submission process on GitLab, which you can work through yourself. I'm happy to have questions about this on the forum if you get into any kind of trouble. But I really would hope that folks start this assignment early. You can definitely start it today if you want to. Make these mistakes with the submission early. Need help early so that we can help you easily and help other people by having documented problems on the forum. Okay. Sorry about my voice today, folks. This is terrible. I don't think I've ever had it quite this bad in a lecture. In recent memory, anyway. So, another little admin topic. If you're new to computing, it may feel a little bit overwhelming, the number of things I've been talking about. We talk about GitLab, we talk about P5, we talk about discourse, got all these different tools. One of your tutors this semester, last year, when they were a student in the class, made this great flowchart of all the different tools in 1720. So if you're ever confused about what you're supposed to do, maybe you could have a look at this flowchart and see what it is. Avery will post this on the forum again a little bit later, but you can see that we definitely have this variety of tools that are required for participating in a computer science subject. And if you're not a computer science student, I can see that that might be a bit threatening, maybe. In other subjects, it's just like there's Wattle and that's it. And in computer science, we've got all these different tools for your computer, things you have to install, things you're required to use. And it can definitely feel a bit overwhelming, but there's help here. So if you ever are confused about something, any way you can get in touch with us is fine, but I will help you to get on the forum ultimately. A few folks are texting me on Teams outside of class. Mostly when people text me on Teams, it's really a forum type question. So from this week, once we all get set up on the forum, I'll start to redirect folks to asking questions on the forum if they have a question. All right, code theory. Today's concepts are, first concept is flow, and second concept is types and variables. So what is flow? What's the flow through this code? Let's get a good color, red. Make a rectangle, make an ellipse, and draw a line. Okay, so the flow is the order in which we actually run this program. We do that one first, rect, then we do the ellipse, and then we do the line. So far, so good, right? And that seems fairly easy, but if we have flow through this code, well, this time we make a line, an ellipse, and then a rect. We're making the same three shapes, but we're actually potentially going to get a different result. So the question is, does it matter here? And if I just copy this into a P5 sketch, whoops, I need to be not in Blackboard mode. I'll just copy this into a P5 sketch. Rect, ellipse, line. Get rid of that. I'll make this a bit bigger so we can see it. Make a white background for us and get rid of that. So there's three elements. We start with our rectangle, then we draw a circle on top, and then we draw a line over here. And if we take the other ordering was line, ellipse, rect. You can see that our picture is going to change. So now, unfortunately, even though we might have wanted to see a rectangle, a circle, and a line, we're seeing half a line and a rectangle. Because as we learned last week, when we're drawing in P5, it's like we're painting over everything that we started with. It's painting on a canvas. So if your order of operations is not correct, you might not get the image you expect. And this is a really common error in drawing in P5. Students come to us in the labs and say, oh, my drawing disappeared. And then we say, okay, well, let's look carefully at what you're doing And we might find that actually they drew their drawing and then they drew the background afterwards. So it looks like there's no drawing here, but they've just painted over the background as the last step. So flowing through your code, it seems like it's an easy concept, but it can easily cause errors. And an error really is the computer doing one thing that's not what you expect, as that kind of error. Because there's no error in the console here. The computer has done exactly what we've told it to do. It's just that we've given it instructions in the wrong order. And I did it myself when I started with this sketch because I had the basic code in the sketch wasn't helping me express this concept. It was drawing the wrong picture. So I had to figure out the flow of execution first before I could actually show you this demo. So code executes top to bottom. It seems like that's simple, but it actually sometimes causes us pain in coding. So remember the painting metaphor. Everything in P5 is painted on top of what was already there. And if you want to clear the canvas, you use this background function to draw over everything. And we can use background with just black and white. With just one number, it's going to give us black if I make it 0, or white if I make it 255. Whoops, too many parentheses there. Or grey if I go in between. And then if I give it 3 numbers, it calls it a color. There's a nice purple, or what is that? It's more like burgundy. Good color. So, one thing that we haven't really explained yet is the sample code we get when we start a new P5 sketch. Here's my sample code. There's this thing, function setup, and then function draw. Well, what does that mean? Why do we have 2 things here? And why are they called functions? So the first thing in this code is that there's a few lines that start with /. And those lines, when you start a line with a /, P5 just ignores it. So that's just a comment for humans to read. But function draw and function setup, what does that mean? I told you last week that a function was something you run. So a function might look like that, set up and we run something. But this bit is actually us defining what a function does. So we're defining a function called setup and defining a function called draw. Now it just so happens that elsewhere in P5, it runs a function called setup, but it doesn't know what that function is until we define it. So we get the chance to define the function called setup. It runs setup for us. Ooh, there's a great question in the chat. I'm going to get to that question in a minute. It runs a function called setup, and then it runs a function called draw. And then it runs another function called draw, and then it runs the same thing again. So it runs setup, draw, 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 draw. And this is where it gets to be a bit more complicated with our flow. This function called setup gets run once, exactly one time, when our sketch loads. So in this sketch, it's only got one line of code, create canvas 400 by 400. So it's going to make a blank canvas for us to draw in. I can make it bigger. These things down here won't really work because I'm just demonstrating them. So it's going to be unhappy with that. Then it will run the draw function, and then as soon as it's finished running the draw function, it'll do it again. So the draw function happens over and over again. So this is what I mean by flow, because when we're running a P5 program, things are always happening. They're happening continually. It may seem like your code just gets run once and stops. And often in other programming classes, that's how it works. We write some code, that runs and then it stops and we see what the output is. P5 is always running. It's always running these draw functions over and over and over again, which can make things a little bit more complicated. Yeah, so this is our loop so far. Set up, draw, 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 draw. So the trick here is that if we draw a square here, rect 200, 200, 50, 50, it's actually going to draw the same rectangle each time. But the exciting thing is if we can get it to draw a different rectangle each time it runs that draw function, then the rectangle might appear to move across the screen. And I'll show you in a minute how we actually accomplish that in P5, which is where things get to be pretty cool, and that's hence the mug. Now things are getting pretty cool. I'm just going to skip ahead and, yeah. I will get back to the question about P5 and VS Code in a minute, but I'll just get through this little topic. So what we have in P5 is this draw function going over and over again. And if you're experienced with other programming languages, it may seem like that's a loop, where you've got a loop of code that runs continuously. And you might write a loop in another programming language like this, while true, do this forever, draw. So that's kind of what's going on. It runs draw and then finishes running draw and then just runs it again. But we are not learning how to write loops today because we've already got one set up for us. This draw function continues to run forever. Now, another new to programming concept. You see these little brackets, the squiggly brackets? In P5 and in many programming languages, the squiggly brackets define a kind of block of code. And that's really important to understand for our flow, because no matter what code we put in here, code, 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 all of this code until the squiggly bracket ends is part of the setup function. And similarly, code that we put in between these squiggly brackets is part of the draw function. And if we put code outside of those functions, it will actually run, but it will happen outside of the context of setup and draw. So it will happen before setup and draw run, and it won't happen after your draw loop. So even if you put code down here, let a equals 0, that's a valid line of JavaScript. But it won't happen after your draw loop, even though it's physically after the code in your file. So the really important thing to remember about flow is these brackets, squiggly brackets, defining a block of code that's all running together within the same kind of temporal context. Oops, that's my video. Another kind of common error we make when writing code is having the wrong number of braces or brackets. So if I put an extra brace down there accidentally, the P5 editor is smart enough to know that that's not going to work. I've got unbalanced brackets. So if I try to run it, P5 complains. That's going to be a problem. Could also happen with regular brackets. Common programming error to accidentally have too many brackets or too few. You'd think that this is the kind of thing that would be easy to spot, but when you've got a complicated program, it might not be. Yeah, so flow gets more complex when we have complex programs, but at the top level, always in this course, we're going to have setup happening once, then draw, 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 draw. you'll have other kinds of flow. Maybe within your draw loop, you'll have some other flow going on that you need to look after. But as a programmer, you need to make sure that you understand how that flow is working. And if you ever see your program working, no errors, but not having the output that you expect, it's probably an issue with the flow. So always remember your flow, and always remember that this is your way of making sure that operations happen in the right order. And that if operations aren't in the right order, you tend not to see what you expect in your P5 sketch. And this sort of brings us to the model of how we expect P5 sketches to work. A P5 sketch is like a series of photos, really, because that's a draw loop. This is a draw loop. Often we have a situation where the setup code will run some code that sets things up once, and then each of our draw function is painting a whole scene on the canvas, and then when it runs again, it paints the scene again. So it's like an animator creating a cell each time, or a photo where you're taking a slightly different photo of a scene and moving through that scene to make it move. So each draw has to sort of completely illustrate the picture, and then the next draw completely illustrates it again. There's a few ways to play with that. We'll play with it a little more in a minute. Yeah, now I think I just want to take a little break to explain this question. I'll just get a new workspace or something. New window. So the question was, what's the difference between VS Code and P5? So the difference is that VS Code is a library of programming code written in a language called JavaScript. And VS Code isn't a programming library like that. It doesn't run code. It's actually an editor. So it's more like Microsoft Word. So if you're asking me what's the difference between P5.js and VS Code, it's like asking what's the difference between a dictionary and Microsoft Word, right? Microsoft Word is a program that lets you type in words, and a dictionary is a book that tells you what each word means. And in some way, the dictionary is like P5, because P5 is going to understand what all of these commands are that we've entered in. It understands what background is, and understands what rect is, understands what create canvas is, and does things in the browser with those when we use those commands or those functions. VS Code doesn't know anything about create canvas, background, or rect. It only knows about how to type in words. Here's some words. How to type in words and save a file. And it has some extra features that are good. Like it's got that live server, which means that you can view an HTML file. And it's got the integration with Git, so we can get our code up onto GitLab. But it's really just like Microsoft Word. It's an editor for words. And something else needs to interpret or understand those words. So the thing doing the interpretation and understanding is actually your web browser, because the JavaScript code isn't running in VS Code at all. It's running in your web browser. And when you click Go Live on the live server and do that in doing your lab exercises and your assignments, that is really VS Code just sending your JavaScript file to the web browser in a way that the web browser can easily understand. You can even open the index.html file in your templates just in a web browser using Explorer or Finder in your computer, and it will probably mostly work. The live server is just a slightly more robust way to do that. Yeah, so I hope that's a reasonable explanation. There's a great explanation in the chat as well, but you can think of VS Code as an editor, just like Microsoft Word, and you can think of P5.js as the interpretation between the commands you're using and what is going to happen in the web browser. All right. Next topic, data types and variables. Here's some numbers. 7, that's an easy number to know. 654, that's an easy number to know. 5.77, it's a floating point number. It's got a decimal number, a decimal point. Oh yeah, great question. We got a follow-up question related to VS Code. Don't we use VS Code to submit our lab? Absolutely. VS Code is a editor with a lot of great features. I could say, don't you use Microsoft Word to create a PDF file? Yeah, of course you do. But Microsoft Word doesn't understand what the words in that PDF file are. You use VS Code to submit your lab because VS Code knows how to take your code and put it onto GitLab where we can access it. And even though you typed background 30 and ellipse 200, 200, 200, 200 into VS Code, you didn't see any of those circles in VS Code itself, did you? You saw those circles come up in a web browser, because the web browser is what's actually running your code, not VS Code itself. I know that this sounds like a crazy topic, right? How can VS Code write, use VS Code to write P5 code, but how does VS Code not understand that code? Well, it's like saying, well, in Microsoft Word, you can write an engineering report, and you can also write an English essay. You can write in English or German in Microsoft Word. It doesn't care. You just change the dictionary, right? And it still thinks the spelling is correct. If you want to see the actual figure, you're always using P5. You actually don't have a choice about that. The way that our lab repos are set up mean that it always includes P5. And if we go to our lab repo, so great questions this week. Lab template. Oh, that's the template, not the repo. Whoops. Here's your lab repo. Week 1. Sketch.js. This is your sketch where you type in that code. But it's also, whoops. When you actually run your script, it actually has this HTML file that your browser will interpret, and it goes and loads a lot of other code from this file, p5.js, which is distributed over the internet. So we can actually just type that in and have a look at what it's getting. And this is the code of p5.js, which is a fairly long file. You can see it's really long. P5 has a lot of detail in it. So this is, whenever you run your code, it runs this all first, and then it runs your bit of code that you're adding on the end. And this is where all of the definitions are of the functions you use in your P5 script. Okay, we'll have to put a pin in the P5 versus VS Code topic for today. We might get back to this on the forum, but and certainly in your labs, you're free to discuss that with your tutor for 2 hours if you want. Let's talk about data types and variables. So we've got some different numbers here. Whole numbers, decimal points. Here's something a bit more abstract, number of planets in the solar system. Your age, a bit more abstract. And a potato. Is that a number? Are these all numbers that make sense? Are they all the same kind of number? You tell me. Comments in the chat, please. Are these the same kind of number or fundamentally different? Some people have said fundamentally different. Okay, great. Well, why are they fundamentally different? Someone said these two are something called an integer. Oh, that's interesting. What's an integer? Do you want to tell me? Oops. What's an integer? And what's this one? Various properties of different things, someone has said. You're going to have to be a bit more precise than that. Some can change and some are set. That's a great explanation, someone's just said. Really like seeing that one. These ones are all like fixed, right? 7 is always 7. 654 is always 654. 5.77 is always 5.77. The number of planets in the solar system, well, in some sense, that's kind of... It's a fixed number, but it's defined by someone, and it can change, because there was a while where we decided that Pluto wasn't a planet, and now we kind of decide that maybe it is a planet again. So it's possible that that can change if people decide to change it. Can change. Your age, well, that's a number which is fixed today, if you call it your age in years, but your age in seconds? Everyone has an age in seconds, don't we? But it's changing second by second. It's only ever the same for 1 second. So this one changes regularly. And then we've got something down here, a potato. Well, this one, I guess it's a bit of a red herring, because at first glance it's not a number. It's a potato. Potatoes aren't numbers, obviously. Are you stupid, Charles? But then someone in the chat has said, well, it's definitely a potato because... It's definitely a number because it's represented by a number in the text encoding, because this HTML file is a text file, and that potato is actually a emoji. Whoops, and I can select it and I can copy it and I can put it other places, and it's a potato. So it's a letter in our text file, really, which is represented by a certain number. And most of the regular letters, A through Z, in English language are supported. There's lots of other emoji, like the smileys and little faces and stuff. And a potato is supported. So a potato has a certain number in this encoding. Oh, someone's posted it. It's definitely, its encoding number is U plus 1, that's a decimal 1, F954. So it is a kind of number, isn't it? Might seem weird, but it is. But also it's just a potato. We don't have to be too crazy about it. There's really two kinds of numbers here that I want to talk about. Some of these are fixed, and some of these can change. That one can't change, that's fixed as well. That's in the fixed bracket. Or maybe the question mark bracket. And we're going to talk today about numbers that can are fixed or change. So far, we've been typing in numbers into our sketches. 800, 600, 255, 100, 100, 100. And then I want to now talk to you that tell you that there's other numbers that you don't type in that look like a number. And this one is called frame count. So let's just copy this code in and see what it does. Ooh, frame count is colored in pink. That's interesting. Something has changed. A change has occurred. My sketch is changing in front of my very eyes, in front of mine eyes. Look at that, isn't that amazing? So, frame count is a number that changes. It's a number that changes every time we go through the draw loop. Frame count becomes one bigger. So it starts at 0 when we haven't gone through the draw loop at all. Go through the draw loop once, then it will be 1. Go through the draw loop again, it will be 2, etc. You can see it steadily increasing as we go through the draw loop. So the name stays the same, but the value changes. Just like your age, the word we use, age, stays the same, but the value of that word changes. So variables, some numbers are always the same, e.g. 100. Some numbers are always the same but have got a name, e.g. pi. Well, pi is a set number. It's always got the same value, but it has a defined name. Some numbers change or vary over time, e.g. your age. So that number is changing regularly. So the definition of a variable in programming, we're going to say that a variable is how we give a name to a value which can change. It could change. This is really handy because often when we're doing sketches in this course, you will want to have numbers that change because you want your draw function to work slightly differently each time. If you only use numbers that don't change, your draw function would always be the same. That's not what we want. The name stays the same, but the value can change. This, again, is a place we can get into trouble when coding because maybe we've got a name that makes sense to us and the value makes sense sometimes, but sometimes that value could become something we don't expect and our sketch could look a way that we don't expect either. And if that happens, again, there won't be any errors. There's nothing wrong with your sketch, but it won't do what you think you want it to do. And that's the real issue with programming in P5. Errors are easy to deal with because your sketch stops working. There's like red errors down in your console. You can track them down and fix them. But making sure your system is correct, not just valid, is what is tricky. Making sure your code is correct, not just valid. So time and change, and this is where we get to do basic animation. Time is represented with numbers, just like position and color. There are different ways to represent time, different ways. But the most common one we will use, and what we're looking at today, is called this frame count variable. You can tell that frame count's a variable and not a function, by the way, because it's got a lowercase f at the start, a small f. If it had a big F, or not a class, if it had a big F, it would have to be a class. A different kind of thing entirely. So frame count can't tell you what the time is. It can't tell you if it's 4 p.m., but it can tell you the time, the number of draw loops you've had since you started running, which can give you a rough indication of how many seconds have gone by and allow you to have moving and dynamic objects in your sketch. We'll play with this variable in a minute, but I just want to point out a few extra ones. Here's some, mouse X and mouse Y. Can you guess what they will do? Well, that's cool. So mouse X is the X location of my mouse in the sketch. And mouse Y is the Y location, or the up-down location. X is left-right, Y is up and down. So now I've got a sketch which is interactive. I can move this square around by moving my mouse around. It's pretty simple, isn't it? But it's a kind of interaction. And we're not going to talk too much about interaction today, or really until we get to week 5, but there's a start, a few variables that give us some interaction. Yet Julian has jumped in to say, now this is pretty cool. We'll get to that bit, Julian. We'll get to the pretty cool stuff. Types. If I said the type of a thing, you might start thinking about Pokemon or characters in a video game. Is it a medic? Is it a what are other things? A paladin or a mage or a rogue? Characters can have different types in stories. Pokemon can have different types: electric, or water, or fire, or fairy, or ghost, or normal. Is normal a type? I think it is. But in computing, we use the word type to refer to different kinds of variables. So in JavaScript and P5, every variable has a different type, sometimes called a data type. And we've got some important ones to tell you about. The important ones in P5/JavaScript are a number. And in fact, in P5, there's no difference about whether your numbers have a decimal point or not. They're both a number. Other programming languages make a big deal about whether things have a decimal point. Well, okay, but JavaScript doesn't do that. You can have a string, which means text. So it's called a string, not text in computing, because it's a string of characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this space is also a character. A space is a character. So if you see quote marks and some text inside a sketch, it's actually a character, actually a bit of text, or it's a string. Hot potato, here's one. So in my editor here, the online P5 editor, it changes to green. We got the Boolean type. It's either true or false. Booleans can be a little weird because you're writing a word, right? But it actually is, it's actually kind of a number. It's just a type by itself. It can either be true or false. Then we've got some other weird ones. Undefined. That's something that P5 doesn't know what to do with. And object. I will have to learn about those in week 4. Excuse me for a sec. Whoops. So, if you look in the reference, where's my reference? The P5.js reference. You'll often see these types as part of the instructions for things. So if we look at, let's go to background. It will say what certain things can be. So background could be 3 things: V1, V2, V3, and A. And V1 is a number, V2 is a number, and V3 is a number, and A is a number. So it's telling you the type of thing that you're allowed to use in those spots in between the commas in the command background. Oops. Yeah, so mostly we often deal with variables that are numbers, but not always. We will often use numbers in this course. So hopefully that's okay for you. If you haven't thought about math a lot since primary school or high school, maybe you'll have to think about a bit more maths, but it's only basic maths, really. Basic arithmetic. You can also create variables of your own. And to create variables really has 3 steps. 3 steps. First step is declare the variable. So you're telling P5 what to call the variable. In this one, I'm saying let age. Second one, initialize the variable, age equals 34. And then we can use the variable later in our code. And when we want it, we just use its name. And it's just as if we'd written 34 there, 2 times 34. Unfortunately, I wrote this code 2 years ago, so The number has changed. Age is not 34 anymore. I wrote this slide 2 years ago. So we can do lots of, you're going to do lots of declaring of variables in your code, and you can combine declaration and initialization in one line. Let max equal 100, let min equal 10. I'll just copy this into a file and show you how that works. Could put it right up the top there, which is fine. No problem. Someone said, can't you ignore the declare step? Well, let's see. Looks like you can't. So I just tried to delete the let. That's the declare bit. Let max, let min. So you can, in some circumstances, you can ignore that in JavaScript. It's one of these things about JavaScript that I can never remember how it works. So folks often tell me about how it works and then I remember for 5 minutes. But just to be safe, if you're making a variable, I would suggest that you declare it every single time if you're making a new one. It's generally good programming practice. So you can also declare a variable to be and initialize it in terms of another variable. So it could let range equal max minus min. So if we had max equal 100 and min equal to 10, range is going to be 100 minus 10, which will be 90. You can even use another function to give you a value that you then store in a new variable. So there's a function called random. We're going to talk about that later today. And we can take the output from random and store it in a value called random value. And that random number is now set. It's not going to change anymore because we've taken it out of the function, we've stored it and kept it safe in our variable. So it's not going to change afterwards unless we decide to change it. So when you modify a variable, if you modify your age, like you have your birthday, you don't say, well, my age is now age 1. You still have the same word, age, but your age value has gone up. So we can change the value of a variable without changing the name. We don't have to make new variables every time. So you can do something like this. This looks slightly strange, but if we've already got a variable called range, we can now say range equals range plus 1. So this is saying, set the value of range to be the old value plus 1. So if range was 90 before, this is going to set range to be 90 plus 1, so set range to be 91. And note that when you're modifying a variable, you don't need a let declaration. You've already declared it, and if you do a declaration, P5 will probably complain that you're trying to do something that you probably don't want to do. Sometimes in some P5 books, code, or even my slides, you might see this word var used instead of let for declarations. Var instead of let. It's actually the same idea. We used to use var all the time in JavaScript for declaring variables, and then at some point they invented a new and better way called let. The details of that go kind of beyond the scope of the course. The scope, haha, people might get that joke. We might talk about that a little bit later in the course, but for now, whenever you declare a variable, please just use let. That's the way that we do it typically in this course. In general, we'll try these things out by using them, and I'll give you a lot more examples today. One little last note about maths. Mostly we will be doing, we will often do a little bit of maths in this course. Basically our goal with our maths is to work out the dimensions of a sketch and put things in the correct place. So like if the sketch is 800 wide and you want it to be halfway, you would say 800 divided by 2, right? So that's kind of primary school maths with basic mathematical operators, plus, minus, times, and divide. So we won't dwell on these specifically, but you'll get a lot of practice in the labs in how to use these things. Okay, halfway through the lecture. We get to have some fun. So, just to bring us back to what we were doing yesterday, or last week, I suppose, we were talking about Mondrian's work, Pierre Mondrian. So one of these little circles is a painting by Pierre Mondrian, and the other one is a program simulating a painting by Pierre Mondrian, made on a very old IBM mainframe computer called an IBM 7094. Which one do you think is the Mondrian? Which one do you think is the computer program? Tell me in the chat. So Xingyu has said that right is the computer-generated one. And Anisha has said that the left is the computer-generated one. Oh, I don't know. So most people think it's about half-half here. Left is computing. I'll have to try to remember what it was. Mondrian. Which one was it? I'm now forgetting which one it actually was. I forgot what the artwork's called. Didn't we look at it last week? I think that the answer here is, there's a lot of people having good arguments in the chat about it. This one is the true one, and this one's the fake one. And I guess, like, the point here is that not that the program is bad in particular, it's just that maybe it hasn't got every parameter worked out. And in particular, I think that the right one, when I look at it, I see it as just not quite aesthetically kind of coherent as the left one. The left one has variation in all of its little squares, and they're placed kind of without particular pattern. The right one has variation with its squares, and they're placed without a particular pattern. But the right one has this kind of messy variation, whereas the left one has a more uniform variation, which seems more aesthetically pleasing and coherent. Anyway, we're not really critiquing the program here, but I guess the point of it is to say that the idea of this, of simulating an artwork is not new at all. Here it is, Computer Composition with Lines, 1965. So this art was created in 1965. That is only 20 years after Mondrian's death, in, I think, 1944. So it was certainly a very, and this is the kind of computer, that's, yeah, IBM 7094, that's the IBM 7094 in the background. All the stuff in the room is the computer, and this is just the keyboard, essentially. The console is what lets you operate it. So this article is linked here with some discussion about experiments in recreating art using these early huge computer systems. And they faced many of the same problems we have, which is that we are getting a computer to draw something for us. And that means we have to enter in every parameter. But we want it to look good, right? So in the goal of the work that produced this simulated Mondrian was to try to articulate all of Pierre Mondrian's decisions in a program. Some of them would be random decisions, so use some randomness or variation in the work, and try to encode that in a computer. And really it was quite novel at the time to do that. Well, 60 years later, it's not really novel anymore to encode artistic ideas in a computer. But it's still fun for us to do it. So we're not doing something that's groundbreaking, but we're doing something which is still satisfying and interesting from an artistic perspective. So the size and location of these particular squares. I guess Mondrian himself chose these, using his instinct built over many years as an artist. And then that instinct was trying to be defined by a particular process of random choices and maybe variables recording previous choices to make sure that that was spaced easily in this program. So for the rest of the lecture today, we're going to play with this idea of random chance in art. So what do we value in art anyway? Can art be random? And how can we use randomness in P5 to make interesting works of art? And I'll talk about a few things related to early 20th century art to begin with. So this is a piece called Constellations by Jean Arp, 1938. And they are shapes from pieces of paper dropped onto a canvas. And Jean Arp was a member of a movement in art called Dadaism. Dadaism was a kind of post-World War I movement of artists who were rejecting previous art. So their thought was that, in short, and maybe in wrong oversimplification, previous art is too much associated with the world order that led to World War I, which was a terrible war, primarily in Europe. It was so shocking to people that they rejected everything that had come before in art and wanted to recreate art in new ways. And one of their ways of recreating art was to investigate new ways of art making that took the artist out of the process. So they weren't making decisions here, they were dropping shapes onto a canvas randomly. Randomly dropping paper shapes. Here's another one, terrestrial forest form, another Jean Arp piece, including elements of randomness, this time in wood. This one's from 1917. Another famous Dadaist was an artist called Marcel Duchamp, who's very, very famous for using random materials, randomizing materials, rather than taking paint and colors and the traditional materials of art making, using things that you'd just find around the place. And often his works were termed ready-made. So this one was called Bicycle Wheel. Very famous piece. This is a recreation of it. There kind of went through multiple versions, even though it's the same artwork. And it's a bicycle wheel attached to a stool. And is it really a bicycle wheel anymore, I guess is the question, right? It's not going to roll around. We're not going to use it in a bicycle. It's not functional, but it's becomes artistic. And now this is probably one of the most famous works from Marcel Duchamp called Fountain, which is a toilet. Turned on its side, and he's signed it with a pseudonym, Mutt, and placed it on a pedestal. And I guess there's sometimes we say to put something on a pedestal. If you're an artist and you put something on a pedestal, it becomes art. Duchamp wasn't the only one doing this. There was other artists in the Dada movement. This artist called Freytag Loringhoven, also von Freytag Loringhoven, created this piece from a bit of pipe and a bit of wood. And its name is God, which is sort of provocative, culturally provocative, to invoke religion as well as do something with pieces of random material found around the place. But that was what the Dadaists were doing. They were randomizing materials, changing culture, trying to change the way people interpreted the world. So let's make some Dadaist art in P5. How do we do that? I had this one before. I want to get back to my this one because I gave it a name, variables and chance. Set up draw. And I think I'd like to do something about similar to what Jean Arp was doing in dropping random shapes. So I'll look into the reference and find some ways to make shapes. I guess I could just do a square to start with. We know how to do that. Where's my squares? Well, I'll start with this nice background. And then I will put a rectangle into my whoop. What's it doing there? Oh, I haven't got a canvas. Whoops. There I go. So I've got a canvas now, and I've got my rectangle hanging out. I'd like to give my rectangle a color, so I might make it a nice, attractive green color. I'll get a bit more blue in there. Yeah. Oh, that's good. So I've got one rectangle, but it's not really random now, is it? But what I can do is use the random number, the random function, to start to get some variation about where I place my rectangle. And what I need to do, oh, bored colorblind people, sorry, I'll make it, it's got different contrast. I think the colorblind folks will still be able to see it. It may not be as much of a contrast as we would, a standard sighted person would see. Random is a function which will give us a random number. But if it just by itself, it will give you a random number between 0 and 1, which is not very useful. I wanted to give a random number between 800 and 800, or 0 and 800. So I can type in random 800. Now it's going to place my rectangle in a random spot. Every time I run the scene, it will be random. Now, so far we've learned how we can make a random shape, but I think I would like to add some extra randomness to it. So I'll make it a random size as well. Random 400, random 400. Okay, so now it's a random, whoops, goes a bit too far off the edge. I might make that only up to 600, so it can't fall off the edge. Well, my problem is that my screen's a bit too zoomed in. So I might make this only 600 by 600 so I can see more of it. So far so good. A few tricks. We can actually, instead of typing in 600, we can use width, which is handy, and height here, because now if we change the width or height of the canvas, we'll still be able to have our shape in the correct place. In fact, I don't want it to be quite the same, the whole canvas, so I might multiply width by 0.8. So now I'm taking 80% of the width and 80% of the height. So this is how you can see how I start to use variables to construct some useful numbers for my drawing. I might randomize the color as well. Oops. You don't have to have everything on the same line. If the line's getting too long, we can just split it up. I'm not going to do anything flashy. Random 255, random 255, and I'll keep the blue level the same. Ooh, that's cool. And I might want to do this a few times. So now we're doing something quite similar to what Jean-Arp was doing by creating some random shapes and then dropping them on the canvas in random ways. And I've got 4 random shapes to drop. People are waiting for my catchphrase, and the catchphrase is, "Now this is pretty cool," because that's what I often say in COMP1720. When we achieve something which is pretty cool, and it's so good that someone made a mug for me with my catchphrase on it. Do you think we could improve this? Tell me some ways in the chat that you think this could be made a better artwork. What's wrong with it right now? I might have lost my loyal audience. I call this one random shapes, I think. Different shapes. Oh, I need not a rect. We could do... Could use circles. I kind of already got random colors, so I'm not going to do that. Use different shapes. I think we can get a... so maybe this one called a quad. And the quad is interesting because you actually have to specify every point. So that's x1, y1, x2, y2, x3, y3, x4, y4. So we could do quads instead of rects. So this is going to be tricky. Quad. I'm just going to copy and paste some code. So we're kind of using... I want them all to be in the same kind of area, right? I want them to be not touching near the edge. So I might make it so they've got a constrained number. We're going to do 0.2 times width. Plus. So they're always starting sort of offset from the edge. Plus 0.6 times width. So maximum will be 0.2 times width plus 0.6 times width, which will be 80%. So 0.8 times width is the max, 0.2 times width is the min, and we'll do the same for height. One, two, so it's 3 and then 4 the last one. Okay, quads get complicated, don't they? I'll delete my other shapes. I want everything to be quads. And I'd like to have 4 of them, because 4 is my theme for the day. I hope it works. Maybe I'll just delete these ones to start with, so we can try it with 1. And make sure we get it working. Oh, there's a cool quad. Now that is pretty cool. Okay, here's one. Well, that looks much neater, actually. I think that the bunching things together technique has made it look a lot more coherent. Josh is a fan of quads. I'm a fan of quads too, Josh. Thanks for the heart to do with those quads. Ooh, transparency. That would be nice. I'd like a bit of alpha. The Dadaist didn't really use transparency, so I'm not that keen on it, but yeah, we'll just leave it for now. We're talking about color next week, so we'll talk more about transparency then, but we could do random background colors, yeah. I might just do it so that the background is kind of low contrast or dark. Ooh. So now the foreground always pops over the background. Now, so a few points. What have I done which is interesting? You certainly can use random to give yourself a lot of change inside your sketch. But I've gone to some effort to make sure that the numbers I put in, I get out, are kind of sensible in the frame of the sketch. So I wanted my background to be dark. So I've made sure that the numbers can't be that high, because if they get too high, the background will get very bright. So it can't ever be white, and it can't ever be bright red or bright green or bright blue. It's always going to be muted. Then I wanted my points of my quadrilaterals to all be inside this middle 60% of the sketch. I wanted it to be inside the middle 60%. So I've done a little bit of maths to manipulate the output of the random function so that they're inside that 60%. And as a result, we've got something which looks a lot more coherent and is a lot more fun. So far, we haven't used flow very much, have we? We've only been using setup to the setup function, which happens once. If I took all of this code and put it inside draw, it would happen over and over again, and that's where we would have to have a flash warning. I'll do it once just so we can see. If we put it in draw, it'll happen over and over again as fast as it can. So it's going to look a bit crazy. If you're sensitive to things that are flashy, just mute your screen for the next 10 seconds. Whoa. And stop. I might just put the one background. It'll be less flashy. One more thing. And we get this kind of, ooh, that's kind of cool. Neato. I'll put my quads back into the setup function and save that. Neat. Yep. Oh, there was a question back there. If it's random, why do we still need to put in numbers? The number I put in is the maximum number it can output. I've got a slide later on. This is 38 right now. Yeah. Random with nothing gives you a number between 0 and 1, so they'll be decimal point numbers. Random 10 gives you a number between 0, or from 0 up to 10, not including 10. Random 25, 50 gives you a number from 25 up to 50. So that would be, there's different ways of controlling the output of random, and that's really important in terms of getting the output that you expect in your artwork. Okay, where were we? Randomizing, oh, the Dadaist randomizing things. Now, all of these artists were, when they were choosing things randomly by throwing elements onto a canvas, they were making the random choice themselves in some way, or using their body to articulate that. And one of my colleagues made a point about randomness and the unconsciousness in this scene by Leonora Carrington represents things that dwell in your unconscious mind, or things that dwell in dreams. And I guess there was a thought that when you were using your body randomly, rolling dice, maybe you're accessing elements of your subconscious mind or dream worlds that exist inside your brain, but you can't access them any other way. So it was a way of sort of adding some mystical or magical elements of our human experience into an artwork by using randomness. I guess when we use a computer to be random, it doesn't quite have the same feeling. But it's still something interesting to consider. Some other famous random art. Can art ever really be random? This is a very, very famous piece of art called Blue Poles by Jackson Pollock. And if you want to see this and you're in Canberra, go to the National Gallery of Australia at the lake. This piece is extremely impressive. It's 4.8 meters wide and more than 2 meters tall. It's a very imposing artwork. And it was created in 1952 and was purchased by the National Gallery in the 70s to great outcry about the value of art. Because when people saw this, it cost a lot of money. It was more than $1 million at the time, which was a huge amount of money for an artwork. And people saw it and they're like, what is this? It's just random paint splashed on something. And they couldn't immediately see the value of it, even though it's definitely extremely striking when you see it in person and definitely valuable as an artwork. So, Blue Poles, there's actually a video, you can see a video demo of some of Pollock's process. I won't go into that now, but you can watch that video later. Pollock had a very set up process for creating things which were just random in just the right way. So it was setting up big brushes loaded with paint and just splattering them in a certain way across the canvas. Setting up a big kind of pipette or a thing for basting a turkey and splashing paint in a certain way. So even though it looks like a mess and is complex and messy, it's got a certain kind of coherence in the way that the patterns are set up because Jackson Pollock was really good at doing randomness in a way that looks good. That's why he was a good artist. So even though these pieces of art use randomness, they're still very artistic and very controlled. Jackson Pollock was certainly a rebel. Someone has said Jackson Pollock was a rebel. Previous question coming up was, where did width and height come from? They're default variables. So there are a lot of variables that are part of P5 that are given to you by default. I wonder if we can find them somewhere. There's width, there's height. System variable that stores the width of the drawing canvas. This value is set by the first parameter of the create canvas function. So we have a create canvas function there. That means we have a width variable. If you don't have create canvas, you default get a 100 width artwork. Very useful variable to use. We'll use that one all the time. So my question is, what are the rules of an action painter like Jackson Pollock? And if we look at a similar painter, this person was Joan Mitchell, and the piece was called Riviere from 1990, much later. Joan Mitchell would stand in front of a canvas and make these random brush strokes with different colors. And you can kind of see, whoops, you can see that there's kind of the outline of a person here, right? And the artist reaching up, and they can only reach up to there. Even if they've got a brush, and even if they're doing things randomly, there will be structure in the way that they're making their brush strokes. So, in creating artworks in random ways, painters have used some limitations in order to give them a certain style. So these artworks are very much styled by the way that a human body can access a canvas when you're standing in front of it. The same pattern again here. So they're not just completely random. They're random within a structure or within certain rules. And that's what I was trying to do in this painting, in this work, was to give myself rules for the randomness so that it looks cool, looks coherent, looks interesting, has personality. That's a good one. So it's still got a lot of variation, but it also has coherence. Now we're sort of moving from randomness to this concept of variation. So here's an artwork or an installation by an artist called Stanley Whitney, called In the Color. And Stanley Whitney had investigated using different colors to make essentially the same painting. You see these paintings are all the same shapes, but using precisely different variations in color to create variation. Now this one is cool. This is quite weird. An artist called Tim Hawkinson, and it's a work called E-Motor. And this is it's a mechanical and electronic artwork, and it's quite, I guess, related to what we do in P5, and related to what you'll do in assignment 1 in creating a monster. So what you see here is this picture of the artist, of Tim Hawkinson. He made a picture of himself. But he cut up bits of his face and attached them to these little mechanisms in the picture so that the little mechanisms can move and give him different facial expressions, so that bits of his face can move around. You can see his lips can move up and down, his eyes can open and shut, his eyebrows can move up and down, and his nose can move around in some kind of funny way, and his ears can move in and out, which is pretty weird, really. So this wasn't just sitting there by itself as a picture, it was a whole system. Here's the controller down here, and here's the artwork on the wall in a different view. And the question here is, where's the randomness? Well, the randomness is down there. If you can see down the lower left corner, there's a little TV screen, and it's an old TV. I guess the kind that had a tube and it was sort of deep, but back in 2000, before you kids were born, we had these old little TVs that were about this big. You know, we didn't have little flat screens that big. That was too expensive. So people had funky little cathode ray tube TVs for putting in their caravan or something, I guess. And also we had analog TV. So if you tuned your TV in between the channels, you'd just see static on the screen. It would just be a random pattern of black and white. And on the screen, he's got lots of little sensors picking up the color or the intensity of the black and white. And those sensors are connected to a circuit, which then uses that random number to change the elements of his face. And you can see the wire coming up here. I don't know, it goes across here somewhere, or maybe it comes across over the floor. And so those electronic signals picked up from the random pattern of black and white on the screen is used to move his face in random ways. So think about what you could do with this idea in making a monster in P5.js. You could make different parts of your monster controlled by variables, and then your monster would move in different ways depending on the input from random numbers that change over time. Another concept related to variation is this idea of TV art. So when you're doing TV art, I know it seems kind of wacky. I guess I do TV art here. We're on YouTube and Twitch and stream, making some art on TV, and I'm breaking it down into steps, allowing you to see what I do. And TV art is often about that. This guy was a famous early TV artist, and he's creating this barn or something, and he's using basic shapes to create it, showing the viewer how you might go from shapes to a scene. And another artist, much later, this guy called Alan McCollum, who was actually related to this TV artist. The artist was Alan McCollum's uncle. He was interested in this idea of breaking art into steps. And so he worked out this way of creating a lot of little sub-shapes and then creating a process for putting these sub-shapes together. So combining 6 shapes into this thing, which is, I guess you could call it an interesting shape or a form. Just like what I've just done with those, putting those shapes on the page, finding some variants, choosing randomly and then assembling in a random way. So there's a certain part of this which is predefined, the sub-shapes, and the process is predefined, but it involves a lot of randomness. And that gives us variation. And Alan McCollum did not just do this to make one shape. He used this to make a lot of shapes. So he could create these artworks where all of the variations, any possible variations, are explored, making little pictures or making physical shapes. So there's ways of using variation in really interesting ways to create amazing artworks. And this would be quite stunning to see all of these shapes in front of you, wouldn't it? So what I want to leave you with today would be a toolkit for variation and randomness in your work. So think about when you're using the random function, which you'll probably use a lot, think about introducing variation rather than noise into your artworks. A noisy artwork is like that one I showed, which had to have a flash warning, right? It's annoying to watch. You want to close your eyes even if you're not sensitive to the flashing. And I would ask you what random variations you can do in P5 already. So we're going to talk in the last few minutes, talk about random as well as frame count. We haven't talked about frame count too much yet. But we can also, another way to get input is from a user. We'll talk more about this later. I'm just discussing it now because mouse X and mouse Y are also variables, but you're not allowed to use them in the first assignment. So you can just sit on those ones and relax for a few weeks. And we'll get to mouse X and mouse Y later. All right, so let's make some random art. Before I close down the slides, I'll just point out that there's plenty of things to read and watch this week. You can see that Tim Hawkinson piece in action. There's some cool examples on the P5JS website. This one's really cool. Randomness across a sphere. But I want to make something with random and with frame count. So I'll make a new sketch. Ooh. So, I think I want to make my shape over here. I think I will make another rect. No, maybe not a rect. What shape options do I have? Where's my reference? Shape. Quad, point, line, circle, ellipse, arc. Could make a triangle. I might just make an ellipse to start with. I'm going to make it a red ellipse. We can adjust it later. And I'm going to make it be in a random location, or maybe a fixed location, but a random shape. I'm going to use another function here I haven't told you about called no loop, because I want to just stop the draw loop. I just want to see my random shape. If I don't have no loop, it's going to flick every frame. Blah. Don't want that. If I have the no loop, it's stuck there. But then I can't use the draw loop because I've stopped it moving. No loop stops the draw loop looping. So I really don't want that. And what I actually think I will do is Circle Gang is back. I'm going to make a few circle numbers. Circle width. Declare them there. I might use them here. So now I've used some randomness, but I'm storing it in a variable. So I'm choosing making the random choice once, and then using it later. So then I will use these ones, shape width and shape height here. Cool. Okay, now I can get rid of no loop because we're not moving. Well, this is exciting. Every time I start my sketch, I've got a different shape. And I've got my draw loop working, but right now I'm not doing anything with it. I could be doing something with it. And what I'm going to do is use frame count to animate my draw loop. So frame count is that default variable, which is set to be the number of times we've gone through the draw loop. And now I've got a ellipse which moves. You can see it's moving a bit in a bit of a jagged way because the frame rate's going up and down a bit on my computer while I'm streaming. That's just typical. I can use another variable here. Let x lock location equal frame count. I can use the y as the x location as well. And they can move in a diagonal way. Someone's asking for several shapes moving together. Cool idea, Xingyu. You read my mind. That's what I wanted to do. Might make some more shapes with other random widths. Shape 2 width, shape 2 height, shape 3 width, shape 3 height. And I might make random colors as well. Shape, color. Oh, I've got to make 3 variables for that. That's going to be tricky. Shape red equals random. I really want them to be bright, so I'll make random between 127 and 255, or 80. I want bright colors, not 800, 80. Shape red. Because I've got to have these 5 variables. The width, the height, and red, green, blue. 5 variables all up. We'll just try it with one shape first, hey? Fill, shape red, shape green, shape blue. And I might do the same for stroke. So it's got the same stroke. Actually, I think I can just write no stroke. Yeah, that'll cut the stroke. Okay, different color. That's a nice color. That's not such a great color. Okay, so we got one random shape. Now I want some more random shapes. There's computer scientists in the audience screaming at me that there's better ways to do this, and it's right, but sometimes I like to do things in a not great way, just to explain it. We can set up all of our random variables. There's no need to make this more complex than it needs to be. Sure, there's ways of storing lots of variables together, but we don't get to that for a few weeks. We can just do things in a simple way. So now I need to make more of these shapes at the same time. I'm going to get 3 shapes. So this was shape 2, right? Shape 2 red, shape 2 green, and shape 2 blue. Shape 2 width, and shape 2 height. And shape 3 red, shape 3 green, shape 3 blue, shape 3 width, and shape 3 height. Okay, now, if I run this, it will work, but it's not going to look as good as it could, really, is it? Because they're all moving in the same way at the same speed, which is not that great. What I think I'd like to do is to make some small adjustments to the way that they move through time. We don't need to declare the variables we just used. Oh, I just forgot to declare them and they all worked. Oh well. I guess we don't need to declare variables after all. JavaScript, eh? If I type let, will they still work? They might stop working because I just can never get the handle of variables in JavaScript. Now it doesn't work. Yeah, JavaScript does a thing where if you just start using a variable, it just assumes you want to declare it. Oh, now it stopped working. That's back. Yeah, we really should have declared them all, shouldn't we? Okay. Thanks for reminding me. I guess I could just type things out for a million years. The problem is, and this is a computer science problem, the problem is that sometimes you want to declare something in a specific way so that, for instance, you might want to use a variable name twice. And in the small programs we're writing, that typically doesn't happen too much. But if your program gets bigger, it might happen. So then declaring them in the correct way is really important in that case. There we go. They're all correctly defined. So I might make them all a little bit offset. Not offset enough, are they? There we go, I've got my offsets. And what I'm going to do is change their speed. So I'm going to get rid of the that. And I'm going to give them each a different speed. Well, they'll move differently. Someone's made a suggestion, which is a good suggestion. But I'm going to say let shape speed, let shape 2 speed, let shape 3 speed. I'm going to get a random number between 0 and 1, just as I said I would. I'm showing you all the different ways to use random today. Random with no parameters, random with 2 parameters, and random with 1 parameter. We're almost out of time, so I better get this artwork wrapped up. Shape speed, shape 2 speed, shape 3 speed. Okay, how am I going to use that? Well, I'm going to multiply it by the frame count. So if it's a number less than 1, it's going to slow down that change. This is getting to be a mess. I needed to put more line breaks in. Get some brackets there. You know, primary school maths, get your bod mass happening. So this one's shape 2. Ah, now they've got different speeds. That's kind of cool. So I would kind of like this to have a bit more variation. So I might add, so they're not completely slow, I'll add 0.25, and then I'm going to broad mass to mean I don't need brackets. Oh, come on, I just like to use brackets too much. Because you know what, I just never quite trust the computer to get it right. This has been happening since I was a first-year computing student, and it's happening today. I don't quite trust the computer to get it right if I don't put the brackets in. So now, I mean, the Commonwealth Games started last weekend, so we've got a Commonwealth Games of ellipses, the Ellipse Commonwealth Games. Whoop. Maybe they're a bit too fast. I'll slow them down so we can see if they... Oh, the green one's taken off. I want them all to start in the same place. I think I'll just remove that offset. And just have these three ellipses in a flat-out race. See which one wins. They're all too close. Oh, the blue one's coming ahead. I think the blue, maybe the yellow one, because it was very wide, had an advantage there. The pink one's taking off. Isn't that cool? So what have we done today? We've got randomness, we've got change over time, and variation happening in our sketch. Using frame count, using random, and using drawing. Oh, we should use sine. That's Josh. We'll get to sine. Has a bit more of an advanced bit of maths to use at this early stage of the course. But yes, we could use sine to give things movement across the screen back and forth. The sine function. Cool. Well, with that, it's 12 p.m. So I think I'm going to call this lecture complete. Make sure you log into the forum. Sorry about my coughing fit earlier today. It seemed to go away after a while, which is good. I think I was just a bit focused on the lecture when we started and my throat closed up. If you've got any questions, drop me a line on the forum. Feel free to ask a question now on the chat. I'll be here for another few minutes to answer them. But I'd like to see people posting random stuff in the forum. Of course, you have to use the forum to do your pre-labs, but the forum is there for you to ask questions or show off something cool. You know, Josh, if you've got a great way to use sine in a P5 sketch, I'd love you to write a short demo in P5 and just plonk it in the forum so that other people can see how to do it. I hope you enjoyed this lecture. I really love seeing these random artworks, particularly this one. I think this is so cool. Okay, folks, I'll say goodbye. I'll catch you next Monday, and I'll be available on the forum for questions in between then. Enjoy your labs this week. Go get to know your tutors. I'm meeting them shortly to just make sure we're all ready for the labs, but have a really fun time, and I'll catch you on Monday. See you later.